All right. So, how did it work? Remember that this investigation was only to draw a star, very normal in your paper. And now I wanted you to use something like a mirror, something like this, that you could see reflection. It can be a small mirror, it can be a big mirror, something like this mirror. It doesn't matter, but I wanted you in the second part of the activity was to draw, but looking at this at the mirror. You look at the mirror, reflects on the star, and then you draw looking at the mirror. That was the important part. The question is, what is easier? Was it easier to draw around the star A or the star B? Which one was easy? Okay, I wanted you to answer that. You're gonna use your book for those answers. So I'm very glad. I'm very glad that you enjoyed it. It was confusing, right? Because it's not easy. Because you're drawing from a reflection. And drawing from a reflection is never easy. Because in a reflection, usually what is on the left side, it is in reality on the right side. So it is confusing because it's the opposite. Now, in this part, we want to know um, what mirrors usually do. We're gonna see the benefits of mirror, the characteristic of mirrors, the benefits, the uses of mirrors, and how they are used in the real world. So mirrors, I will start reading, and you will pay attention with me and your book. Mirrors are usually made out of ordinary glass or coated plastic. The back of the mirror is covered with a shiny metal foil that is designed to reflect light very well. So yes, a mirror like this has a transparent part here of glass, and behind the glass, on the back of the glass, you have a shiny metal foil. That is what allows the reflection. Mirrors are good reflectors. I continue reading. Many other shiny objects reflect light well. Of course, we know the reflectors. We saw that the last courses. In the last lessons, we saw that metal are very good reflectors, glass and plastic. Let's continue reading. Dark, I'm sorry, dark and black objects do not reflect light very well. We saw that too. That happens to opaque objects like my shirt, like my cap. They do not reflect because they are dark. This is because the light beam cannot bounce off the surface as well. It is absorbed. So the light comes and it bounces in a mirror. But when the surface is like my shirt or my cap or it's dark, the light comes and it doesn't bounce. It stays right there. Now, I'm gonna continue with some questions. There are some questions on the book that you need to answer. Where are you going to answer those? You're going to go to CIGEDUC platform, and there is something called forum. The forum is the place where I'm going to write down these questions, and of course I'm gonna ask you to kindly answer those questions in the forum in the CIGEDUC platform. These questions are, I'm sorry, why are mirrors used on the inside and the outside of a building? Why do you think? Why do you think mirrors are used on the inside and the outside of a building? Question number two. Which are the reflective surfaces of the building? Imagine that you're in a building. You need to tell me which are the reflective surfaces of the building. And question number three says, which surfaces are dull? in a building. Which surfaces are dull? Dull means that it does not reflect light. How can reflective surfaces be a problem? That is a good question. What do you think about that? How can reflective surfaces be a problem? I continue reading. Mirrors are very useful. They help us to see things that normally cannot. People who drive vehicles, like me, like the teacher, like your father, like your mother, like your grandfather, use mirrors to see behind them. You may be able to arrange some mirrors to explore how this works. And the main question here says, is it possible to use mirrors to see the back of your head? Can you see the back of your head using mirrors? How? That is a very good question. Alright, so the next part of this lesson involves an experiment. And yes, we're gonna use some materials to make our own periscope. A periscope is something that you use to watch from the distance when you cannot reach. Okay, do you see the picture? There are some kids in there trying to look at something, but some can, some cannot. So in this case, we're gonna try to use a periscope to look to the other side, okay, using mirrors. I'm gonna continue reading this part and I will tell you a little bit more about the periscopes later. So mirrors have many other uses. This is important to remember. Dentists and doctors use them to see into difficult places. For example, a dentist has to be able to see behind your teeth. And you know that in our mouth it's difficult for a dentist to see. So they use a mirror to help him or her to look at inside our teeth. Mirrors are also used to make the light in a torch brighter. We're gonna see that later in an experiment. If you look closely at a torch, the surface behind the bulb is usually like a mirror to make the light more intense. And this happens also to the light of the car. If you look at the light in a car, there's a very small light bulb. But surrounding the light bulb, there are many mirrors that what they will do is to intensify the power of the bulb, and they will make light brighter. This is the basic effect. Also in a torch, if you look at a torch, the torch has a very tiny bulb, but it's surrounded by foil paper or sometimes mirrors. This helps to intensify the light of the little bulb. The question here says, how can you see or how can you use a piece of aluminum foil to make a bulb brighter? That's what I was talking about. In your investigation notebook, you're gonna draw a diagram. This is we're gonna do it later because I wanted to talk to you about the periscope. The periscope is the instrument we're gonna make, and the materials are right here. You need a ruler, 4 pieces of cardboard, 2 little mirrors, hot silicone. If you don't have it, you can have white glue, or you can use just tape. So in the next class, in the next video, you need to have these materials because I am going to teach you how to make a periscope with your own hands. Isn't it cool? So thank you for listening to me, and thank you for watching this video. Please go to the forum part to answer the questions I just mentioned, and I will see you then in the next video. Bye bye.